Okay, so now let us solve the part 3 of question number 1 of exercise 4.3, which says that find the roots of the quadratic equation if they exist by the method of completing the square. So the given equation is 4x square plus 4 root 3 x plus 3 is equal to 0. So let us rewrite this equation once again. The equation is 4x square plus 4 square root of 3x plus 3 is equal to 0. Let us compare this equation with the standard quadratic equation. The standard quadratic equation is ax square plus bx plus c is equal to 0. So if we compare these two equations, the given equation and the standard quadratic equation, so we will find the value of a, b and c. So from here a is 4, b is 4 square root 3 and c is 3. So from here first we have to find out whether the root of this equation exists or no. So for that we have to find the value of discriminant d. So discriminant d is given by b square minus 4ac. So we will put the value of b, a and c into this equation. So the b is 4 square root of 3 square minus 4 into the value of a is 4 and the value of c is 3. So this will be equal to 4 square is 16 and root 3 square is 3. So 16 into 3 is 48. Okay, minus 4 into 4 is 16 and 16 into 3 is again 48. So this is equal to 0. Now the condition for the root to exist is that our d should be greater than equal to 0. So in this case, because d is equal to 0, hence the root of this quadratic equation exists. So we will write hence root of given quadratic equation exists. Why they exist? Because the value of d is greater than equal to 0, and in our case the value of d is 0, means the value of d is equal to 0, so it is satisfying this condition. Now if the root exists, then we have to find the root also. Okay, so now let me rewrite the given equation once again. The given equation is 4 x square plus 4 square root of 3x plus 3 is equal to 0. Now remember one thing, in this kind of equation where the value of d is equal to 0, we need not to add or subtract anything, because in this case this particular term is itself a complete square. Okay, here we need not to complete this square, because if we will closely examine these three terms, they will be the square of, they are complete square in itself. So what we will do is, we will try to find out, we can write this first term as 2x whole square. Okay, the last term we can write as root 3 square. So we are getting some hint that the value, if I want to make it as full square, so the first term is 2x and the second term is root 3. The middle term I can write as 2 into a is 2x and b is root 3. Okay, if you will see, this will come out to be 4 root 3x. Why? Because 2 into 2 is 4 root 3 into x. So basically, if you can see, if you compare this term with the standard formula, so we will come to know that this is a square plus b square plus 2ab. Here a square is 2x, b square is root 3, and 2ab is this middle term. Okay, of course this is equal to 0. So now I can write this whole term as equal to a plus b whole square. Okay, so now I will write this term as a plus b whole square, where the a is 2x plus b is root 3 square. So this is equal to 0, right? Now I can write this as two x plus root 3 into 2x plus root 3 is equal to 0. Okay, 2x plus root 3 whole square can be written like this, right? Now I will equate both this term and this term equal to 0 to get the root of this equation. So 2x plus square root 3 is equal to 0, or 2x plus root 3 is equal to 0. So from here my 2x is equal to minus square root 3, or 2x is equal to minus square root 3. X is equal to minus square root of 3 by 2, and from here x is equal to minus square root of 3 by 2. So these are the two root of this quadratic equation. Okay, the one root is this is two root. One root is root 3 by 2 and other root is also root 3 by 2. Okay, now you should remember from this equation, you should remember one thing, that whenever the value of d discriminant comes out to be 0, in that case both the roots of the quadratic equation are real and they both are equal, right? So always remember this, whenever the value of d comes out to be 0, so it is very easy because your term is already a perfect square and the root of the equation are equal.